In today's note, we're going to be looking at the discriminant. And the goal of this is to basically determine how many real roots a quadratic equation has without actually locating them. So in some cases, we just may want to know how many x-intercepts there are, and that way we can get a general sense of what the function looks like without actually having to go through and specifically find the exact values. So just recall that the zeros of a quadratic function refer to its x-intercepts of the graph. And there's three different scenarios, and we've touched on some of them before. We can have two zeros or two x-intercepts. So we would have a quadratic function that looks something like this, where we can see it crosses the x-axis in two spots, or we can see another one over here like this. 1, 0 is where it touches only at the vertex. So that means the vertex is the only spot that's touching the x-axis. And again, two examples. And no zeros, we would see something that looks like this. So that means they're not touching the x-axis at all. All three scenarios are still considered quadratic functions, so there's nothing wrong with either three. Remember, the zeros of the x are the zeros are the x values that solve a quadratic equation in the function or standard form ax squared plus bx plus c equals 0. The method used to determine how many zeros a quadratic has depends on the form of the equation. So again, it depends on what type or what form we're given. So we know that there's three forms: vertex, factored, and standard. So it depends on what form we're given. Remember, in factored form, the key things for factored form were the r and the s value. Those values told us what the x-intercepts were. That's why in the past we wanted to factor or use the x puzzle or product and sum to get to the factored form, because it told us what the x-intercepts were. So looking at the example here, y equals 3 times x minus 4 times x plus 2, if we were to solve for x, we would find that our x-intercepts, we would have positive 4 and negative 2. Again, remember, it's the opposite of those values that we see there, but either way, in the end, we have two zeros. So it's going to look something like this first scenario up here. In the second one, if we're solving for x, negative 2x times x minus 5, we would look at the values that are in the brackets with x. So this negative 5 is an easy one. It's the opposite, so it's actually plus 5. If I look at this second one, x, there's nothing in the brackets with it, so it would have to have a value of 0, because if I add or subtract 0, there's no actual reason to actually show that. But again, I still have two zeros. And lastly, y equals 2x plus 4 squared. So this is a condensed factored form. It almost looks like vertex form, but it's not, because there's nothing at the end. So I can actually rewrite this as 2x plus 4 times x plus 4. Again, remember, the squared means it's this bracket twice. So that means if I solve for x, I get x-intercepts of negative 4 and negative 4, which is basically the same thing. So I only have 1 0. So that's looking at x-intercepts from factored form. In vertex form, if I wanted to find the vertex form, I could expand it and then factor it and then work my way down. But there's an easy way. If I just want to figure out the number of zeros, not specifically what they are, just the number of them, I could sketch if necessary, if it helps you to visualize it. But if I find the vertex and determine in which way it opens, then I can figure out how many x-intercepts or zeros there are. So if I look at the first one, my vertex is going to be 4, negative 3. Again, looking at these two values. My a value is 2. So my vertex, I know, is 4, negative 3. And, the vertex is below the x-axis because that y value is negative 3. So that means if I were to draw a rough sketch over here, my vertex would be down here. So I'll just draw a quick sketch for the first one. You can see where I'm kind of headed. So my vertex is down here. My parabola opens up because it is a 2 and it's positive. So that means in order for it to open up, regardless of what the step pattern looks like, it's going to cross the x-axis in 2 spots. So I'm going to have 2 zeros. For the next example, the vertex, again, very similar. It is 4, -3. The a value is -3, or sorry, not -3, -2. So that means that my vertex is still below the x-axis, but now my parabola opens down. So if I were to roughly sketch that, my vertex is still here, but now that it opens down, I'm not touching the x-axis at all, or I'm not going to touch it, so that means there are 0 zeros or no zeros. And finally, for the last one, my vertex is 4, 0, because of the 4 and there's nothing added after, so it's 4, 0. My a value is 2, so that means my vertex is on the x-axis, because the x value is 0. The parabola opens up, so that means there is 1, 0. And again, if I were to draw a quick sketch of what that would look like, it's on the x-axis, say over here, and then it opens up. So it's only, again, touching on the vertex. So that's how, if you had vertex form, how you could figure out how many zeros there are just by looking at the equation. Finally, standard form. Standard form, to determine the number of zeros, we have to use the quadratic formula, which was our last lesson. So our quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. Or we could use a graphing calculator or other technology to sketch it and see what it looks like. So we're going to start off by using the quadratic formula first, and we can verify if you want by using Desmos to come up with a sketch of what it looks like. But again, the main thing is we want to find our a, b, and c values. In this case, I'm going to use the same colors as before. In this case, it's already organized and set equal to 0. So just remember that the a is with x squared, b is with x, and c is the constant on its own. So when I plug in my values, I get -2 plus or minus the square root of -2 squared minus 4 times -3, all divided by 2 times 4. So I get x is equal to, simplifying, +2 plus or minus the square root of 4 minus -48. So this is the same one as we did in the last note, divided by 8. And then I can simplify it even further. X equals 2 plus or minus the square root of 40. This one's slightly different. So 52 divided by 8. So here I would break off into 2 parts. X equals 2 plus the square root of 58, 2, I'll do that right now, 7.2 divided by 8, x equals 2 minus 7.2 divided by 8. So we get basically 1.1, and if we have 2 minus 7.2 divided by 8, get -0.65. Just confirm this with Desmos. Which does work. So if these, basically we have our two x-intercepts here. So if we were to sketch those, we would have one roughly here and here. We could then figure out, we know our y-intercept comes from the last value in our standard form equation, so -3 is our y-intercept. We could figure out our vertex if we really wanted to, but we know that it's going to be basically look something like this, but the main idea is that we have two zeros. That's the main idea. Let's try the next one. So we have our values, so we need to know our A, our B, and our C value. So our C value is the constant, and this may seem repetitive or a lot, but at least it's a good review of the quadratic formula. And then our A and B value. So I'm going to plug those in. So I'm going to have -12 plus or minus the square root of -12 squared minus 4 times 5 times 9, all divided by 2 times A, or times 5. Oops. So if I simplify, I get x equals 12 plus or minus the square root. -12 squared is 144 minus 180, all divided by 10, and get x equals 12 plus or minus the square root. So 144 minus 180, -36 divided by 10. And here we would break this off into two parts, because now we've simplified it pretty much as we can. So you have x equals 12 plus square root -36 over 10, and x equals 12 minus the square root of -36 over 10. But what you will find out, if you try to take the square root of a negative number, the only thing you're going to get is an error. So that error is fine. We talked about this in the quadratic formula note. That error is fine. That basically means that you're not going to get any value, which means there are no x-intercepts. Again, I would just double check just to make sure that your values are, your calculations are correct. It's not an error. So what we can do when we want to sketch it, we can still know our y-intercept is up at 9. So that means we have a y-intercept up there. We can't really find the vertex right now based on what we know, because we can't find the x-intercepts and find the middle value. But what we can do is we can graph it or sketch it from Desmos, and we should get something that looks similar to this. And this basically means that we have no zeros. And then lastly, the last one, again, our A, B, and C values, we want to find those from the standard form equation. And once we know those values, we're going to plug them in. So we have negative B, so -2 plus or minus the square root of -2 squared minus 4 times 1 times 1, all divided by 2 times 1. Get x equals, and now we're just going to simplify, so 2 plus or minus 4 minus 4, all divided by 2. If I simplify, x equals 2 plus or minus the square root of 0 divided by 2. And we've had something similar to this before, so if I simplify this, I have 2 plus or minus 0 divided by 2. And either way, if I break this off, if I add or subtract 0, it's not going to matter. I'm still going to get 2 divided by 2, which equals to 1. So in this case, I have one x-intercept, and it is on 1. I know, again, I can find my y-intercept, which is here. So if I were to sketch my parabola, it would look, oops, keep it consistent. It would look something like this, which means I only have 1, 0. So these are the 3 examples that we can come across when given standard form. Now, this is not a nice way to have to go and do it, to have to find or use the quadratic formula every single time. I'm sure you found it very tedious, but there is an easier way. And that's basically what we're going to look at now, which is the discriminant. So the discriminant is basically this part of the quadratic formula, the b squared minus 4ac. So basically the method from method 3, or from what we just did with the quadratic formula, the portion of the quadratic formula, and specifically it was the b squared minus 4ac, provided a means to determine the number of roots. And this portion is called the discriminant. So basically this portion tells us the number of roots. It doesn't tell us what they are, but it's going to tell us how many roots there are. And so if I look back at them, if I look at, these are the same equations from what we just did, and again finding the a, b, and c value, I'm just going to go through and do all of these at once, so that it's a little bit easier on the highlighting and it's not as tedious. Again, remember, a is in front of the x squared, b is in front of the x, and c is the constant on its own. So if I just do this portion of the quadratic formula, so in this case, negative 2 squared minus 4 times 4 times negative 3, and I get 4 minus negative 48, which I can then simplify to 52. So if I get 52, I know that from this example I had 2 zeros. If I go to my next example and I do just this portion, I have b squared, so negative 12 squared negative 12 squared minus 4 times 5 times 9, which was 144 minus 180, which gave me negative 36, and I had no zeros, or 0 roots. And for the last one, if I have b squared, so negative 2 squared minus 4 times 1 times 1, at 4 minus 4, which equaled 0, and I had 1 root. So basically, in conclusion, if my discriminant, or the b squared minus 4ac, or basically the number or the portion under the square root, if it is greater than 0, then I have 2 zeros. If it is less than 0, or we'll put in brackets negative, which meant the top one was positive. If I have a negative value from that discriminant or the portion under the square root, I have 0 zeros. And if it equals 0, it means I have 1 0. So all I have to do, if I'm only concerned about the number of roots, without graphing, and I have the standard form, I can just do this portion, or the discriminant, or the b squared minus 4ac. So let's go through 2 examples. I'm going to use the discriminant, or the b squared minus 4ac. I need to find my a, b, and c values still. And now I can just plug these values in. So my a is 1, or so my b is negative 4, so negative 4 squared minus 4 times 1 times 3. I get 16 minus 12, which gives me 4. So because I have a positive value, that means therefore there are 2 roots, or 2 zeros, or 2 x-intercepts. So I know it's going to either look something like this or like this. Because I know my a value is positive, that means it opens up, so it has to look something like this, crossing the x-intercepts. So something like that, whether it's over here or it's shifted over so that it's actually in the negative side, I know it's going to look something like that. And finally, for the second example, again, find your a, b, and c. So again, still is very similar to the quadratic formula, except you don't have to do the full long formula because we're only concerned about the number of roots, not the actual roots. So then 2 squared minus 4 times -1 times -3. So we have 4 minus, this would be 12, so you get -8. So because it's a negative value, therefore we have no or 0 roots. So this was just kind of a quick overview of finding the x-intercepts, regardless of what type of quadratic formula or quadratic function you're given, vertex, factored, or standard form. But it's given us a simplified way to find the number of x-intercepts or roots if we're given the standard form by just doing the b squared minus 4ac, rather than having to do the entire full quadratic formula. So it just gives us a better way to visualize what the graph will look like.